Common logs and natural logs are similar in that they're special cases of logarithms. A common log is a logarithm with base 10. Now, when you're using a calculator, generally, unless you're using one of the fancy graphing calculators where you can change the base, a log on your calculator is in terms of base 10. So that is considered a common log. And we're going to just talk about common logs a little bit first before we move into natural logs. With that being said, a common log, like I said, has a base of 10. So let's say that I have log of base 10 of 13. And we're trying to figure out what that equals. Now, on your calculator, you will be able to type that right into your calculator as log 13. You will not need to enter the base because the calculator already assumes that it's a base 10. Unless, of course, you're using the nspires, then you need to actually type in your base. So if I just type this right into my calculator, it'll come out with 1.11394 approximately. So I can type that right in, and there are specifics here that we need to talk about. This portion right here, this is what we call the mantissa. The number in front of the decimal, this is what we call a characteristic. Just some fancy terminology there. Now, a couple days ago, you guys were asking me about what to do when it's in the exponent, when the value of the variable is in the exponent. This is what we call a natural anti-log. So for instance, if I were to have log of base, we're just assuming this is log of base 10. So if I just write log, you can assume that it's a base 10. So if I have log of x equals a, if I want the anti-log or the inverse of this, this is going to then be x equals the anti-log of a. Now, in order to use your graphing calculator, or any type of calculator, doesn't have to be graphing, you're going to hit second or shift log, and that's going to get you your anti-log. Just to kind of give you a little bit of practice. So, looking at this, you are going to hit second log, and that should pull up a 10 to the power key. And then you'll type in whatever your a value is. So in this case, 6. And that's going to give us 1 million. Just got 6 zeros there. Okay, so anti-log isn't that big of a deal. It's just a second or shift of the actual log. Now, a natural log. A natural log is pretty darn similar. So we've dealt with the number e. E is that special number that's 2.718. We dealt with it when we were compounding continuously. Exponential growth, exponential decay. Well, a natural log has a base of e. And we write this a little bit differently. We don't actually write log of e. We actually write ln. And you'll see that there's a special button on your calculator for the same thing. So when we're doing this, you might have natural log of, say, 6.4, and that equals x. So you just type that right into your calculator and it'll calculate it for you. You can also find the anti-natural log. Again, it's the same type of concept. You hit second or shift of your ln. Instead of a 10, because 10 was the base for the common log, this is going to pull up an e to the power. And some of you might actually have it backwards, where you need to not hit shift and you need to hit shift for the ln button. It all just kind of depends on your calculator specifically. But again, all of this is represented on your calculator in terms of log and natural log, and it's all just it's a special case because you have a different base that is known to most people. And we're going to use this a lot more when we're dealing with solving for exponential equations. So this is something just to note, but otherwise, this is the gist of what a common log is and what a natural log is.